In our earlier previous session, we had discussed several properties of definite integrals. We are continuing with that. And for applying the next property, I want my function to be monotone, integrand to be monotone. Suppose f of x is a monotone function. In the beginning, let me assume f of x is an increasing function. Increasing means it need not be increasing throughout the domain. It's enough it is increasing in the interval of integration. If for every monotone increasing function, for every let me write it like that. Integral a to b f of x dx. If it is possible to integrate it accurately, it's fine. Otherwise, you can assign some bounds for the value of the integral. My property says it will be greater than the area of the rectangle. My function is increasing, starts from a low value, goes on increasing. It will be greater than or equal to area of the rectangle with width equal to the length of the interval and height equal to the least value attained by the function, in this case f of a. So it will be greater than or equal to b minus a into f of a and will be less than or equal to b minus a into f of b. What I am meaning is just this. You have an interval of integration. In this interval, function is monotone. What you are required to compute is this area. Clearly, it is greater than the area of this rectangle. What is the area of this rectangle? Width b minus a, height f of a. And it is less than or equal to area of this rectangle. Width is b minus a, height is f of b. That's what I am claiming. Similarly, if a function is monotone decreasing, opposite happens. What will be the result? Integral a to b f of x dx will be greater than or equal to, our function is decreasing. So, least value lower bound, a lower bound for the value of the integral will be b minus a into least value attained by the function, and that is f of b, because my function is decreasing. And an upper bound is b minus a into f of a. To apply the property, our function need be monotone in the interval of integration. Outside it may be anything. I didn't mention that, but that is understood. For example, particularly useful when your function is not practically integrable in terms of elementary functions. You know, there are several functions of that type. E power x square, cos x by x, 1 by log x. For such functions, very, very useful property. This is one of the most useful property. For example, suppose you are required to find, it's impossible to find by our methods. Suppose you want to have some idea about the value of this integral. We cannot carry out integration in terms of elementary functions. But I can certainly say, because in the interval 1 to 2, this is a monotone function. It's a monotone increasing function. Do you agree? Therefore, it must be greater than or equal to length of the interval 1 into value attained at the starting point e to the power 1. And must be less than or equal to length of the interval again 1 into value attained at the right hand point e to the power 4. Is it clear? Over any interval in which this function is monotone increasing, I can apply this property. Property is applicable even if this upper limit is root 2. Okay? Suppose the interval is 0 to 1. In the interval 0 to 1, is your function monotone? Yes, monotone. Is it monotone increasing or monotone decreasing? Increasing only. Same relationship continues to hold. Suppose the limits are minus 1 and 0. In the interval minus 1 to 0, function will be a decreasing function. Is it not? You know the applications of differentiation. You know how to check whether a function is increasing or decreasing. What is the derivative of a to the power x square? A to the power x square into 2x. When derivative is positive, function is increasing. Is it not? Am I right? Derivative negative, function is decreasing. If x is negative, function will be decreasing. The opposite, am I right? Derivative positive, function is increasing. Is it not? I don't know. And if the derivative is negative, function will be decreasing. Is there any confusion? So, you may take the help of that idea and write the proper inequality. One more example. Suppose your function to be integrated is cos x square. Interval of integration 0 to root of pi by 2. Is your function monotone? In the interval 0 to root pi by 2, is cos x square a monotone function? Yes. Monotone increasing or decreasing? Decreasing. Therefore, an upper bound will be, for a decreasing function, where is the highest value attained? At the left hand point. What is that value? Cos 0, 1 into width of the interval, root of pi by 2. It will be an upper bound. Agree? And a lower bound will be least value attained. Is the value attained at this point? What is it? 0 into width of the interval, 0. The property says this must be a number between 0 and root of pi by 2. One more example. Suppose your integrand is 2 to the power x square. Say 0 to 1. Is the function a monotone increasing function? Monotone increasing or decreasing? Increasing. Therefore, a lower bound will be, least value attained is 2 to the power 0, 1 into width of the interval, 1. Highest value attained is, highest value is 2 to the power 1, 2 into width of the interval, 2. You can even be definite about this inequality. Will be strict. Because this is not a constant function with height equal to 2 everywhere. Its starting value is 1, ending value is 2. It is increasing, not a constant function. Therefore, this inequality cannot be less than or equal to, it must be strictly less than. This also must be strictly less than. When do you get equality? If the rectangle area and this area are equal to each other, then you get equality. In this case, you are sure that these two are unequal. This area is smaller than this area. You are definite about that. Okay. Why do I require that? Suppose I am asked to find the integer part of the value of this. I can be very sure about that integer value. Without carrying out integration, I can say integer part must be equal to 1. Our next property will be concerned with differentiation of a definite integral. Suppose you have a definite integral like 2 to 3 f of t dt. I am asked to differentiate this with respect to x. What will be the derivative? Okay, let me fix the function. Okay, what will be the derivative? What problem is there in guessing the value? Not guessing, in predicting the value. This is a constant, this is a pure number. Definite integral is a pure number. None of the limits of integration is a variable. Each limit is a constant, therefore value is a number, derivative must be equal to 0. Suppose the upper limit is ax, a variable x. What will be the derivative? Now the derivative will not be 0. It may be some other function of x. It will be some function of x. What will it be? I will just explain it this way. Suppose indefinite integral e power t square dt, or even general case, let me consider. Okay, f of t, general function. Suppose one indefinite integral, a particular antiderivative is g of t. Actually, what is the meaning of this? When do you say for a function f of t, g of t is an antiderivative? This simply means derivative of this is f of t, means g dash t equal to f of t. Now suppose you have a definite integral, some constant to variable x, f of t dt, and you are interested in finding derivative of this function. What is actual value of integral a to x f of t dt? If this is an antiderivative, then value of this definite integral must be how much? Antiderivative found at upper limit minus antiderivative found at lower limit. But in this is a number, constant, therefore g of a is a number, its derivative will be 0. And this is not a number, this is a function of x, derivative with respect to x will be another function. What will it be? Derivative of g of t with respect to t is f of t. What is derivative of g of x with respect to x? Must be equal to g dash x is f of x. How do you get it from here? Simply consider the integrand, ignore all other things. In the integrand, replace t by x. What you get is the derivative. So, what is derivative of this? E to the power x square. What is derivative of this? Cos of x square. What is derivative of this? 3x square plus 1. What is derivative of this? Okay. Now my result is not as it is applying. You must treat this as a product function, a product of 2x plus 1 and integral 2 to x dt. Agree? The function to be differentiated is this product function. What will be the derivative? First function into derivative of the second. What is it? The integrand with t replaced by x. Integrand is 1. In 1, you replace t. Wherever you find t, get it replaced by x. You are not finding t anywhere. So, what is it? 1 plus integral 2 to x dt. What is integral 2 to x dt? You can tell me its value. X minus 2. Is it right? Or simply x? X minus 2 into derivative of 2x plus 1, 2. This will be the derivative. Is the logic clear? Yes, I think. Okay. Next, suppose the function to be differentiated has x at the lower limit and upper limit is a constant. What may be the derivative of this with respect to x? Let me come back to this same old thing. Let integral and indefinite integral is g of t. Derivative must be equal to f of t. What I am required to differentiate is this, which is equal to g of a minus g of x. What will be the derivative? For this number, derivative 0. For this, minus g dash x. What is g dash x? F of x. That means you just consider the integrand, replace t by x, attach a negative sign to it. If x is at the lower limit, attach a negative sign. If x is the upper limit, keep it as it is. So, what is derivative of this? Minus f of x. Simply minus f of x. Derivative minus e to the power x square. Derivative minus cos of x square. Okay, next let me consider, say this. Let all these things apply once again. What I am required to differentiate is integral a to x square f of t dt. And when you perform integration, apply the limits, you will be getting g of x square minus g of a. This is the function to be differentiated. In this, g of a is a constant number, derivative 0. For this part, derivative will be g dash x square into derivative of x square 2x. But you know g dash t is f of t. So what is g dash x square? F of x square into 2 of x. So what will be your policy now? In the integrand, replace t by upper limit, get it multiplied by derivative of this x square 2x. Is it clear? Suppose you find x square as lower limit and some constant as upper limit. Same thing with the negative sign. Suppose you have an arbitrary function g of x as lower limit, another arbitrary function h of x as upper limit. What will be the derivative then? Same policy again extended will be f of h of x into derivative of h of x minus f of g of x into derivative of g of x will be the derivative of the function with respect to x. Whenever you have a function expressed as a definite integral, this is the policy to be applied in finding the derivative. Will be e to the power t square, where t equal to x cube, to be multiplied by derivative of x cube minus integrand with t replaced by x square, e to the power x to the power 4, to be multiplied by derivative of x square 2x. What will be the derivative? Integrand with t replaced by sin x, cos of sin x, to be multiplied by derivative of sin x, cos x. Nothing to be subtracted because lower limit is a number, constant. Integrand with t replaced by upper limit multiplied by derivative of the expression appearing as upper limit minus integrand with t replaced by lower limit to be multiplied by derivative of what you are finding as lower limit. Agreeable? I think I have few more examples. All very simple exercises. Will be one by log x square, 2 log x, multiplied by derivative of x square 2x minus 1 by log x to be multiplied by derivative of x 1, or it is x by log x minus 1 by log x, x minus 1 by log x. Now you are ready for another variety of problems. Your curve will be described by an equation of the form, say x to x square, some f of t dt. A function will be defined by an equation like this. Definitely, certainly it defines a curve. What will be the equation of the tangent at a point on it? What is the equation of normal at a point on it? Suppose two curves are given in this form, or one curve this way, another curve in the normal manner. What is if exists an angle of intersection? In which interval this function will be increasing? At which point this will attain a maximum? All sorts of problems can be tried now, but we will take up those problems later. Now let us finish a study of the properties. Then, as miscellaneous set, we will take up more problems. Okay. Next property called Walle's formula, used in finding values of definite integrals of the form 0 to pi by 2 sin to the power mx cos to the power nx dx. Whenever an integral is of this form, you can directly determine its value applying a formula due to Walle's called Walle's formula. Now we will be obtaining that formula with the help of one of the reduction formulae derived by us earlier. As an exercise on reduction formula, we had derived a few reduction formulae. We will use one of them. Using it, we will obtain a formula for evaluating this integral. You remember that reduction formula obtained for integrating sin to the power mx cos to the power nx dx. As I remember, we have derived one formula for this, minus 1 by m plus 1 m plus n not into x of x. Okay. Okay, that is a factor. M minus 1 by m plus n integral m minus 2x cos power nx dx. Right? Yes. We must have obtained a reduction formula for integral cos power mx dx also. Have we? Because that also we will require to finish the job here. One by m okay plus integral cos power n minus 2x dx. Oh, it's not cos. Cos power. Okay. We can't have a reduction formula for this in terms of another function. It must be in the same function with a lower degree. Okay. We know this formula. We have derived both these formulae earlier as exercises on reduction formula. Let us apply limits now. What do we get? This at x equal to pi by 2. 0. Because of this factor, value is 0. At x equal to 0. 0. Because of this factor, it will be 0. So, the value of this expression at x equal to pi by 2 is 0. Value at x equal to 0 also is 0. So, what remains will be minus m minus 1 by m plus n integral 0 to pi by 2 sin to the power m minus 2 x cos to the power n x dx. Once again, you repeat the formula with m replaced by m minus 2, n as it is. What are you going to get? Minus of m minus 1 by m plus n into one more minus sign. Now your m has got replaced by m minus 2. This will become m minus 3. Agree? M has got replaced by m minus 2. N has retained its old value. So, m plus n minus 2, agree, into similar integral with the still lower order 0 to pi by 2 sin power m minus 4 cos power nx dx. Agree? When you apply same formula once again to that, you will be getting minus m minus 5 by, so hope you are following, m plus n minus 4 into integral 0 to pi by 2. Again, index has got further reduced. Continue this until you get the index of sign reduced to either 1 or 0, depending on whether m is even or odd. If m is even, you will end with final value becoming 0. If m is odd, the value gets reduced to 1. There we will stop. Okay? So, let me break this. Suppose m is even. Where will we stop? When we reach the index of sign equal to 0. Then the integrand will be simply cos to the power nx dx with limits 0 and pi by 2. What will be the last coefficient? It will be negative of, when the index of sign is m minus 2, the numerator of the last factor in the coefficient will be m minus 1. When the index is m minus 4, it will be m minus 3. When the index is m minus 6, it will be m minus 5. When the index is 0, it has to be. When the index is m minus 2, this is m minus 1. In what is the relationship between these two? Is this equal to this, or some number, some quantity less than that or more than that? It is more. How much more? 1 more. So when the index has become 0, this will be 1. 1 more than that index. What about denominator? First factor m plus n. Then the index is m minus 2. Or let me consider only the first portion of this. Second part always remains here. First portion m is 1 more than this. First portion m minus 2 is 1 more than this. The portion m minus 4 is 1 more than this. So now it will be 2 plus n. N will be there as it is. And if n is odd, we will be arriving at sin x cos power nx dx if m is odd with limits 0 pi by 2. And the last coefficient will be minus of 1 more than this index 2 by 1 more than that index 3 plus n. Agreed? Other things as they are. We have to copy all these things as they are. Now to finish the job, I will have to evaluate this. That will be done taking the help of this formula. And in this case, there is no need to apply this formula. I can finish more easily applying one substitution. Substitution cos x equal to t, sin x dx equal to minus dt, reduce the limits of the integral, easy to finish the job. And when you carry out all these computations, you will get the formula. We start with m minus 1. It next gets reduced by another 2. Further reduction of 2, m minus 5. Continue like this until you reach 1 or 2. Depending on whether m is even or odd. If m is odd, we will stop when we reach 1. If m is even, we will stop when we reach the value 2. Into n minus 1 as we did on m, n minus 3, n minus 5, continue as before, stop when you reach 1 or 2, divided by, start with m plus n get it reduced by 2 to obtain the next factor, further reduction of 2 to obtain the next factor, again will be continued till you reach 1 or 2. Then the whole thing that you have obtained will be multiplied by a constant k, where what is this k? K will be equal to pi by 2 if m and n are both even, and in all other cases it will be 1. This is a formula which you have to remember. Very easy to remember. In numerator, the difference of any two consecutive factors is 2. Denominator also same thing. Starting factor m minus 1. Reduce it until you reach 1 or 2. Next set starting factor n minus 1. Reduce till you reach 1 or 2. In denominator, we start with m plus n, no reduction. Whole value m plus n. Go on reducing it till you reach 1 or 2. And if both m and n are even, multiply by pi by 2. Otherwise, leave it as it is. What you have obtained is the value of the definite integral. You have actually a simple method for evaluating this. How do you evaluate? You can simply write this cos cube x as 1 minus sin square x into cos x. Apply substitution sin x equal to t. Very easy to evaluate. But you have a ready-made formula. Why go through all those computational exercises? Value will be 4 m minus 1 into 2. Stop here. One set is finished. Next set starts with 2. That itself is the last term of that set. Divided by m plus n 8. Next factor 6. Next factor 4. Next factor 2. Are both m and n even? No. This itself is the value. 4, 2, 4, 2 cancel. 1, 2 cancels. 1 by 8 into 3, 24. m minus 1, 9. Next factor 7. Next factor 5, 3, 1. Next set n minus 1, 4 into 2 divided by m plus n 15 into 13 into 11 into 9 into 7 into 5 into 3 into 1. Are both m and n even? No. That's all is the value of the integral. Whatever simplification possible, you may try that. m minus 1, 3 into 2 less than that 1, n minus 1, 5 into 2 less than that 3 into 2 less 1, divided by m plus n 10 into 2 less 8, 2 less 6, 2 less 4 into 2 less 2. Are both m and n even? Yes, into pi by 2. Same policy, you accept m to be 0, that's all. m 0, n equal to 10. So, no factor corresponding to the first set. The only factors will be of the form 10 minus 1, 9, 7, 5, 3, 1. m plus n is 10, 8, 6, 4, 2. Are both m and n even? Yes, into pi by 2. The other index is to be taken as 0. Three, 1 by 4 into 2 into pi by 2. Pi by 2 occurs because both the indices 0 and 4 are even. 0 to pi by 4 sin square 2x cos power 4 2x dx. As it is, my formula is not applicable because the upper limit is not pi by 2, is pi by 4. Also, the argument of the sin and cos functions are not each equal to x, they are each equal to 2x. Let me apply a substitution, get it reduced to x. It is worth trying because I have a ready-made formula for 0 to pi by 2 sin power mx cos power nx, whose advantage I must take. So, applying the substitution, 2x equal to y. I find my integrand as sin square y cos power 4y dx is dy by 2. New limits are when x equals 0, y equals 0, when x equal to pi by 4, y equal to pi by 2. Have we arrived at a situation where the Valence formula is applicable? Yes. One more situation of the same form. Now you will apply the substitution x by 2 equal to t, get the integrand converted into a function of the form sin power mx cos power nx, and simultaneously limits also will be changed to 0 and pi by 2. You can try it. The substitution you have to apply is x by 2 equal to t or x by 2 equal to y. Next case. Any idea? No need of even applying the Valence formula. You have a still simpler method. The integrand is odd, limits are minus a, value is 0. Next case, integrand is not odd, it is even. Therefore, it will be twice 0 to pi sin to the power 4 x by 2 cos to the power 5 x by 2 dx. And how to get this converted into a form where Valence formula is applicable? Substitution, x by 2 equal to t. Then zero to infinity dx by 1 plus x square to the power 6. Does not look like a problem where Valence formula is applicable, but through a substitution even this can be brought to a form where you can make use of that formula. The substitution you apply will be x equal to tan theta. Good. Integrand becomes secant square theta d theta. Denominator 1 plus tan square theta is secant square theta to the power 6 is secant to the power 12 theta. The new limits are when x equal to 0, theta equal to 0, when x equal to infinity, theta equal to pi by 2. Is simply 0 to pi by 2 of cos to the power 10 theta d theta. One more situation where we directly do not find that the Valence formula is applicable in this case also, but through a substitution we can bring the integrand to a form where you can apply that formula. The substitution you require will be, first let me apply method of completing squares and find the integrand as x plus 1 whole square plus 4 whole to the power 4. Now we find a convenient substitution for evaluating this integral is x plus 1 equal to 2 tan theta. The integrand becomes 2 secant square theta d theta divided by 4 tan square theta plus 4 is 4 secant square theta to the power 4 is 4 to the power 4 secant to the power 8 theta. The new limits are when x equal to minus 1, tan theta 0, theta 0. When x equal to infinity, tan theta infinity, theta pi by 2. Almost all simple, usable properties of definite integrals we have discussed till now. Now we are in a position to tackle any given problem on definite integrals. We will have a miscellaneous set of problems. No method, no hint will be suggested, given to you. Directly looking at the problem, you have to decide which method is most convenient to apply in that given situation. Apply that method, get the answer as quickly as possible. That kind of problems, a few problems I have brought with me. ಇದವ್ರ ನೋಟ್ಸ್ ಕೊಡ್ತಿರಲ್ಲ ಸಾಕು. Any suggestions? Partial fractions. We will have to write 3 partial fractions. One with denominator x minus 1, second with denominator x minus 1 whole square, third with denominator x square plus 1. Of the 3 numerators, the second numerator can be obtained by inspection. How? Applying x equal to 1 everywhere except in the factor x minus 1 whole square. You get that numerator as 2 minus 1 plus 2 plus 1, 4 divided by 1 plus 1, 2. Even this numerator is easily obtainable. What you do is, you try that value at which x square plus 1 is 0. When is x square plus 1 0? X equal to I. We will try that value. We will apply the value everywhere except in the factor x square plus 1. What do we get? This will be 2i cube minus 2i. Am I right? Minus I square plus 1 plus 2i plus 1 divided by I minus 1 whole square. I square is minus 1 plus 1 minus 2i. These things cancel. Make the denominator real. How? Multiplying numerator and denominator by ai. It becomes, this minus 2i plus 2i also have gone. So 1 into 1, 2 into I divided by minus 2I square is 2. Am I right? It's equal to simply I. That means this numerator is x. That was the substitution that you have used in getting this. Suppose you get, on simplifying this, suppose you get I plus 1. That will mean numerator is x plus 1. Suppose you get, on simplifying, 2I plus 3. That means numerator is 2x plus 3. Okay? Good. Only one numerator remains to be found. Suppose this is A. Then, on applying common denominator, I will be obtaining A into x minus 1 plus 2, A into x minus 1 into x square plus 1 plus 2 into x square plus 1 plus x into x minus 1 whole square. I want this to be equal to 2x cube minus x square plus 2x plus 1. Compare any one of the coefficients involving. I will compare x cube coefficients. A, no x cube term, there is a x cube term here 1. A plus 1 must be equal to 2. Therefore, A is 1. Is the job remaining a comparatively simpler job? Just writing the integrals and applying the limits. Will you finish it on your own? Yes. I wanted to explain this procedure of obtaining numerator of a partial fraction corresponding to a quadratic factor. With that objective, I took up that problem. The rest is simple. Integration, then applying the limits, simplification. Okay. Any suggestions? If the numerator, this numerator is free from this constant term, you have one method. And when numerator has that constant term present, the method will be different. The method you have to adopt will be another one. If the constant is missing, what will be the method? Write the numerator as some constant into denominator plus another constant into derivative of denominator, decompose the integrand, carry out term by term integration. When there is a constant term, I think the only method that you can try is tan x by 2 equal to t. Even if you split, at one stage or other, you will have to depend on that substitution. At some other place, you may have to apply that substitution. Why not wait? Why wait till that step? Let us apply the substitution here itself. When the integral is definite, you are going to change the limits of integration also through that substitution, and the problem will not remain that complicated. If it is an indefinite integration problem, what you said may be worth trying. But when it is a definite integration problem, you can try substitution at the beginning itself. So, integral becomes 3 into sin x is 2t by 1 plus t square plus cos x is 1 minus t square by 1 plus t square plus 1 divided by sin x is 2t by 1 plus t square plus 2 cos x is 2 into 1 minus t square by 1 plus t square, and dt is 2 dt by 1 plus t square. New limits of integration, tan x by 2 0 means, x 0 means tan x by 2 is 0, x is pi by 2 means tan x by 2 is 1. On simplifying, you will be finding the integral as 0 to 1 of what? Numerator 6t plus 1 minus t square plus 1 plus t square. It will be 6t plus 1 minus t square plus 1 plus t square. Minus t square plus t square cancel. Will it be simply 6t plus 2? Yes. 2 plus 6t okay, divided by denominator. One factor in denominator will be 1 plus t square, and other factor corresponding to this denominator, how much? 2t plus 2 minus 2t square. 1 2 common, I can cancel against this 2. So what remains will be t plus 1 minus t square. Am I right? 1 plus t minus t square. Right, I think. Yes. How to continue? How to continue further? Partial fractions. Straightforward. When the integrand is a rational algebraic fraction, no thinking. Method is partial fractions. Is it possible to factorize this? If possible, get it factorized, then proceed to find the partial fractions. Otherwise, you have to continue as it is. I think this is not further factorizable. So, keep the factors as they are. Write two partial fractions, obtain their numerators. Numerator of this partial fraction easily obtainable, applying t equal to I. Similar procedure can be applied here also, provided you write this in a complete, completing square. Squares completed in that form. This is negative sign, let me take outside, then it becomes t square minus t minus 1, that will be t minus half whole square minus 5 by 4. Am I right? Negative sign has gone outside. Now what remains is t square minus t minus 1. Are you getting t square? Yes. Are you getting minus t? Yes. Are you getting minus 1? Yes. So this will be the expression. What value you can try now for obtaining the numerator? T minus half equal to okay, this is factorizable. Is it not? This is in the form a square minus b square. It is factorizable. No need to. Huh? Okay, you get irrational factors. You do not want to deal with irrational factors. Fine. What value you can try then? T minus half equal to plus or minus root 5 by 2 can be tried. Any one of the two values you can try. On simplification, you will get an expression of the form a into root 5 plus b. It may be cumbersome to apply the method, but I am describing you the procedure. Many times this helps us in finding the numerators comparatively easily. You try this substitution everywhere except in this expression. Any one of the two you take, not both of them. Either you take t minus half equal to plus root 5 by 2 or minus. Any one of the two. Apply it everywhere except in this. Simplify. Even rationalization of denominator you should do. Finally, you will be getting an expression of this kind in numerator. Now you write this part as, suppose you have used this one, you write this as this into 2a. Now this will be your t minus half. Replace this by t minus half, get it simplified, what you get will be the numerator of the partial fraction corresponding to this. That way also numerator can be obtained, or another method, take it as at plus b, obtain this first, the next one you take it as at plus b, comparing the degrees or coefficients of like terms, you can obtain the coefficients a and t. Should I continue, complete the problem, or will you do it on your own? You will try. Fine. Method? X plus 1 equal to t square. Right. Good. X plus 1 equal to t square gives the integrand as dx is 2t dt. Root x plus 1 is t. X plus 1 is, next factor x plus 2 is t square plus 1. Next factor x plus 4 is t square plus 3. Am I right? The new limits of integration, x is minus 1, x plus 1 0, t 0, x is infinity, x plus 1 infinity, t infinity. This t can be cancelled against this t. You will be left with 2 by t square plus 1 into t square plus 3. Again, method will be that of splitting into partial fractions. 2 partial fractions you will be getting, one with denominator t square plus 1, another with denominator t square plus 3. How will you obtain the numerators? You have a simpler method now, no need of I, because the expression is free from odd powers, is containing only even powers. Just apply t square equal to minus 1 everywhere except in this. This t should be removed first, only after removal, apply t square equal to minus 1, you get the numerator of the first. Apply t square equal to minus 3, you get the numerator of the second. Very easy to find. In some problems, you may even get expressions like numerator, say 2x square plus 1, denominator x square minus 4 into x square plus 3. There is a need for splitting, breaking this into partial fractions. My advice to you, do not factorize this. If you factorize this, this advantage will be lost. You retain it as it is and write it as sum of two partial fractions. One with denominator x square minus 4, another x square plus 3. How is first numerator obtained? Applying x square equal to 4 everywhere. Applying x square equal to minus 3 everywhere, second numerator. And there is no difficulty in integrating a fraction with denominator x square minus 4. You have ready-made formula. There will be no need to break it further into two more partial fractions. Anta advantage iddaga never lose it. ಹೀಗಿದ್ರೆಯಾ ಹೀಗ ಡಿನಾಮಿನೇಟರ್ ಕೂಡ then it will be factorizable. ಆಗದೇ ಇರುವ ಕ್ಯೂಬಿಕ್ ಇಲ್ವೇ ಇಲ್ಲ. The only non-reducible polynomials are linears and quadratic with negative discriminant. All others are factorizable. Every cubic is factorizable. Every biquadratic is factorizable. Suppose you come across an expression like this. How do you get this factorized? Idondu popular expression which we come across very frequently. Just write this as x square plus 1 whole square minus x square. Then you will be able to get the factors. Idu one expression matra. In general, factorizing a biquadratic may not be easy. ಇಂಥ ಎಕ್ಸ್ಪ್ರೆಷನ್ ನಿಮಗೆ ತುಂಬ ಸರಿ ಬರ್ತದೆ, ಅದಕ್ಕೋಸ್ಕರ ಹೇಳಿದೆ. ಇದು ನಾನು ಮೊದಲೆಲ್ಲಿಯೂ ಹೇಳಲಿಲ್ಲ, ಅದಕ್ಕೋಸ್ಕರ ನಾವು ಐ ಆಮ್ ಮೆನ್ಷನಿಂಗ್ ಇಟ್. ಓಕೆ, ಇಲ್ಲಿ ಆಡ್ ಪವರ್ಸ್ ಇದ್ದು, ಒನ್ ಸೆಕೆಂಡ್, ಇಲ್ಲಿ ಆಡ್ ಪವರ್ಸ್ ಇದ್ದು ಥ್ರೂ ಔಟ್ ಆಡ್ ಪವರ್ಸ್, ಡಿನಾಮಿನೇಟರ್ ಈವನ್ ಪವರ್ಸ್ ಅಂತ ಆದರೆ ಈಗಲೂ ನಿಮಗೊಂದು ಅಡ್ವಾಂಟೇಜ್ ಉಂಟು. ವಾಟ್ ಯು ಡೂ ಈಸ್ ಯು ಕೀಪ್ 1x ಔಟ್ಸೈಡ್. ಹೀಗೆ ಟ್ರೀಟ್ ಮಾಡಿ. ಇದನ್ನು ಪಾರ್ಷಿಯಲ್ ಫ್ರಾಕ್ಷನ್ಸ್ ಸ್ಪ್ಲಿಟ್ ಮಾಡಿ, ಯೂಶುವಲ್ ಮೆಥಡ್. ಆನಂತರ ಎಂಡಲ್ಲಿ ಎಕ್ಸನ್ನು ಒಳಗ್ತಾನೆ. ಓಕೆ, ಇಟ್ ವಿಲ್ ಬಿ ವೆರಿ ಸಿಂಪಲ್. ಸಪೋಸ್ ಯು ಹ್ಯಾವ್ ಆಡ್ ಪವರ್ ಇನ್ ಒನ್ ಪ್ಲೇಸ್ ಆ್ಯಂಡ್ ಈವನ್ ಪವರ್ ಇನ್ ದ ಅದರ್ ಪ್ಲೇಸ್. ಯು ಬ್ರೇಕ್ ಇಟ್, ರೈಟ್ ಇಟ್ ಆಸ್ 2x ಕ್ಯೂಬ್ ಬೈ ದಿಸ್ ಪ್ಲಸ್ 1 ಬೈ ದಿಸ್. ಎರಡನ್ನು ಸಪರೇಟಾಗಿ ಪಾರ್ಷಿಯಲ್ ಫ್ರಾಕ್ಷನ್ ಮಾಡಿ ಕಂಟಿನ್ಯೂ ಮಾಡಿ. ಇಟ್ಸ್ ವರ್ತ್ ಟ್ರೈ. ಅಷ್ಟು ಆ ಬ್ರೇಕ್ ಮಾಡಿದ್ರಿಂದ ಪ್ರೊಸೆಸ್ ಲೆಂಗ್ತಿ ಆಗ್ತದೆ ಅಂತ ಹೇಳೋದು ಬೇಡ. There will be advantages also in breaking like that. Okay. So this you will finish. Good. Next one. Any ideas? Think of a substitution which helps you in rationalizing this. X equal to 1 by t. Does it work in this case? I have a better substitution. Think of one using which you can rationalize. You can get rid of the radical sign here. X equal to secant theta. Even the form of these numbers should give that hint. What will happen to our integrand? Numerator secant theta tan theta d theta. Denominator 3 secant square theta plus 1 and root of secant square theta minus 1 root tan square theta is tan theta. And new limits, when secant theta is 2 by root 3, cos theta root 3 by 2, theta is pi by 6. Upper limit, secant theta to cos theta half, theta is pi by 3. ತಪ್ಪಲ್ವಾ? cos pi by 3 half, ಸರಿ ಅಲ್ಲ? ಕರೆಕ್ಟ್ ಅಲ್ಲ? ಓಕೆ ಓಕೆ. tan theta cancel. Convert everything into an expression involving only sin and cos. In this case only cos. What do you get? Multiplying numerator and denominator by cos square theta. Numerator becomes cos theta, correct? Divided by 3 plus cos square theta. How to integrate? Write cos square theta as 1 minus sin square theta. One more substitution, sin theta equal to t, cos theta d theta equal to dt. Finish. Good. Now, you have an idea. You have attempted that earlier. Numerator yes. Yes. No help from your side. You have the idea with you. You have attempted it earlier. No idea? In one of your earlier sessions, you are practicing problems here, and one problem Farday brought to me saying that I find some error in this, and I suggested one correction. He recorded it for your consideration. He copied that, and you found later that the original problem itself was solvable and the new problem given here was not. What idea did you use in solving that original problem? Divide numerator and denominator by 1x cube. Dividing denominator by x cube will be simply dividing the expression inside by 1x. Is derivative of this exactly equal to this? Yes. What will be the new limits? When x equal to 1, 7, new upper limit when x equal to 2, 8 minus 2, 6, plus 4, 10. Two x equal to cos square 2 theta you want? Okay. Or simply theta. Cos square theta or cos square 2 theta? 2 theta. Okay. One minus cos 2 theta divided by 1 plus cos 2 theta into dx is cos 2 theta into minus sin 2 theta into 2 d theta. New limits when x equal to 0, cos square 2 theta 0, cos 2 theta 0, 2 theta is pi by 2, theta is pi by 4. Upper limit 2x equal to half, x equal to half, 2x 1, cos square 2 theta 1, cos 2 theta 1, theta is 0. Is 2 into integral 0 to pi by 4. How do we get this integrand simplified? We multiply under the radical sign, we multiply numerator and denominator by 1 minus cos 2 theta. Direct, how? One second, what is that? Huh? 2 sin square theta, 2 cos square theta, tan theta, 1 theta. Okay, then one second. I think for my method, I didn't require that 2 theta. Doesn't matter. One second. I will multiply numerator and denominator by 1 minus cos 2 theta. Under the radical sign, multiply by 1 minus cos 2 theta. This becomes, root will become 1 minus cos 2 theta. This becomes 1 minus cos square 2 theta, sin square 2 theta, root of that sin 2 theta cancels. What are you left with? 1 minus cos 2 theta into cos 2 theta d theta. Am I right? Is this not more easily integrable? There was no need to bring in this 2 theta here. 1 theta would have been enough. Doesn't matter. 1 cos 2 theta integral is sin 2 theta by 2. By 2 by 2 cancel. Sin 2 theta between 0 and pi by 4. Sin pi by 2 is 1. minus 2 cos square 2 theta. 2 cos square 2 theta is 1 plus cos 4 theta by 2. Among the terms 1 plus cos 4 theta by 2, for 1 by 2, integral is theta by 2. When you apply the limit, it becomes pi by 8. Into 2 has been taken care of. 2 cos square 2 theta is okay. By 2 I should not have considered. Is simply 1 plus cos 4 theta. For 1, integral is theta. When you apply limits, it will be pi by 4. Then next term cos 4 theta, integral is sin 4 theta by 4, which is 0 at each of the limits, 0 and pi by 4. So the final answer just this much. Actually there was no need to take 2 theta, 1 cos square theta would have been enough. But there is nothing wrong in taking cos square 2 theta. Okay. Next problem, hint. Numerator is a constant, denominator square of a quadratic. First, apply the method of completing squares to the quadratic in denominator. Am I right? Then think of a substitution which simplifies this form, this expression. What substitution? Using what substitution you can simplify, get the denominator substantially simplified? Yes, right. 2x plus 1 equal to 3 tan theta. Our integral will become dx 3 secant square theta d theta by 2. Denominator 2x plus 1 whole square is 9 tan square theta plus 9 is 9 secant square theta, square is 81 secant power 4 theta. The new limits, when x equal to minus half, 2x plus 1 is 0, 3 tan theta 0, theta is 0. When x is 1, 2x plus 1, 3 tan theta 1, theta is pi by 4. Express in terms of cos, get the job finished using formula for cos 2 theta. Root x plus 2 by root of cube of x minus 4. An expression of the form ax plus b to the power m into cx plus d to the power n. You have a substitution which is most convenient to apply when m plus n equal to minus 2. It can be tried even in other cases, I have told you. Right. X plus 2 by x minus 4 equal to t square, or reciprocal of that, any one of the two. Either x plus 2 by x minus 4 or x minus 4 by x plus 2, whichever is convenient to you. Take that as t square and continue. Which is preferable to you in this case? The one which, when differentiated, gives x minus 4 whole square in denominator. Which one? X plus 2 by x minus 4. I will prefer that to be taken as y square. Expression for dy will be given by is this x plus 2 by x minus 4 simply 1 plus 6 by x minus 4? Writing x plus 2 as x minus 4 plus 6. Agree? 1 plus 6 by x minus 4. So while differentiating, you can discard that 1. You need simplify only 6 by x minus 4. What will be the derivative? Minus 6 by x minus 4 whole square. Agree? This will be the expression for 2y dy. I'll have to make use of these things in simplifying the integral. So, to bring in dx, I will require x minus 4 whole square with dx. You keep this in reserve to bring in that dy. The remaining things will be root x plus 2 in numerator, and as a result of writing x minus 4 whole square in denominator, you have written something extra, something unwanted you have inserted in the denominator. You have to balance it by writing the same thing in numerator. What will it be? Root x minus 4. Agree? So, numerator will become root x plus 2 into root x minus 4. I am just changing the form of the integral. I have not yet applied the substitution. Limits remain the same, 19 by 4 to 6. Little more preparation before applying that substitution. Let me write this as 19 by 4 to 6. Let this be kept as it is. This is needed to bring in dy. Now this one I will write it as root of x plus 2 by x minus 4, so that I can apply replacements easily into what adjustment? X minus 4. Okay. This will be, now apply, go to applying the substitution. Root x plus 2 by x minus 4 is y. Dx by x minus 4 whole square is minus of y dy by 3. It remains to replace this by an equivalent in y. For that I need an expression for x. You have this. My requirement is to find x minus 4. I will find the individual value of x from this. This is x plus 2 equal to y square into x minus 4. Therefore, what is x equal to? 2 plus 4y square divided by coefficient of x on the right. Am I right? Y square minus 1. Using that, what is my x minus 4 now? Subtract 4 from each side. This minus 4 gives me common denominator y square minus 1, numerator 4y square plus 2 minus 4y square plus 4. And that will be 6 by y square minus 1. Agreeable? Yes. The new limits, when x equal to 19 by 4, this will be 19 by 4 plus 2. How much is it? 27 by 4 divided by 19 by 4 minus 4, 3 by 4. 27 by 4 by 3 by 4, 9, y is 3. And when x equal to 6, 6 plus 2, 8, by 6 minus 4, 2, 8 by 2, 4, y square equal to 4, y is 2. Is this a simple job to execute? Yes. 2 minus 2 let me have outside, or let me interchange the limits and have it as plus 2 into 2 by 3, integral 2 to 3. How much? I am having y square in numerator, y square minus 1 in denominator. Let me write the y square in numerator as y square minus 1 plus 1. Okay. ಆಯಿತಾ? ಟೈಮ್ ಆಯಿತಾ? ಎಷ್ಟಾಯಿತು? ಓಕೆ, ಟ್ರೈ ದೀಸ್ ಪ್ರಾಬ್ಲಮ್ಸ್. ಅದು ಇಷ್ಟು ಮಾಡ್ಬೋದಾ? ಟೈಮ್ ಉಂಟಾ? ಎಷ್ಟು ಈಗ? ಎಷ್ಟು? 6:55 ಆಯಿತು. ಆ್ಯಕ್ಚುಲಿ ಟೈಮ್ ಎಷ್ಟು ನಮ್ಮದೀಗ? 6:45 ಆಗಲ್ಲ ಸಾಕು, ಮತ್ತು ಅದು ಲೇಟ್ ಆಗ್ತದೆ. ಹಾಂ, ಆಯಿತು, ನಾಳೆ ಕಂಟಿನ್ಯೂ ಮಾಡ್ತೇನೆ. ಥಿಂಕ್ ಅಬೌಟ್ ದ ವೇರಿಯಸ್ ಹಿಂಟ್ಸ್. ಹೌದು, ಪ್ರಾಬ್ಲಮ್ಸ್ ಇರ್ತದೆ ನಿಮ್ಮದೇ ಕ್ಲಾಸಲ್ಲಿ. ಇದು ಬೇಡಲ್ಲ, ಇದಾಗಿದೆ ಅಲ್ಲ, ಎಲ್ಲ ಸಿಂಪಲ್ ಪ್ರಾಬ್ಲಮ್ಸ್, ಏನು ಕಷ್ಟ ಇಲ್ಲ.